Hello dear students, a very good afternoon to all of you. Welcome back to another video of this robotics series. This series is all about Master Arduino like a pro, and we are here once again with a new project and a new video. So let's get started. I hope that you have been enjoying the previous few videos, and we'll keep on coming with more videos, and we'll cover more projects so that you get much more better at Arduino projects. Well, if you are new to this video, let me introduce myself to you first. My name is Ahmed Sir. I'm a robotics and coding expert. I have over 12 years plus of experience, and I'm a senior master teacher at sisyaclass. I've taught around 1.2 lakh students all across the globe, and robotics and coding is something that I have expertise with. Right, so without further ado, let's get started. First of all, I would really like to welcome all of you to this sisyaclass. All of you are welcome to sisyaclass so that you can, get the best out of these videos in this series. Well, in this video series, we have planned, many projects that we will be covering in today's session, right? Fine. And out of all the projects that we have today, that we are gonna cover is Arduino motion detection. And the problem that we are gonna solve is how to detect motion using PIR sensor. Okay. And we'll try to understand the physics aspect of this sensor, how this sensor actually works, how we can do the programming aspect, and we'll see that how motion detection can actually be done. Basically, we will be creating a project where the motion detection will happen and it will alarm you. This project can be used in cases where you want to keep something safe from someone, right? And you need to ensure that no one crosses a certain range, right? And the moment someone crosses that certain range is when the alarms will get activated, and you will be informed about that. Okay, so this is the objective for today's session. Without further ado, let's move ahead. Alright, so in today's session, we are going to interface with PIR sensor, and we'll talk about this PIR sensor in great details in the coming few slides. Okay, however, in the previous session, we understood how to use a temperature sensor. Well, that was the first sensor that we used in our series, right? And the output that sensor was giving us was an analog input for the Arduino. In today's session, rather than using an analog input, we are going to go ahead with digital input. Okay, and this project will help you understand that how you can deal with sensors which give you digital signals. Okay, fine. So basically what we understand from this point is that PIR sensor is a motion detection sensor, and second thing is that it gives out digital signals, and we'll discuss about that in great detail. Okay, once we understand that how PIR sensor actually works, next thing that we can do is create the project. Okay, so the project that we have over here is creating the motion detection system, and this is how it will look like basically. All right, so are we all ready to go ahead with this? Give me a thumbs up in the chat so that I can see the energy level coming in from the chat section. All right, let's move ahead now. Fine, so this is the first thing that we need to understand, the PIR sensor. Okay, now until unless we don't understand how the sensor actually works and what is the purpose and the terminals, it becomes really very difficult for us to understand that how to use this sensor in our program. Okay, so we'll do that one by one. First of all, we'll see that how it actually works. Okay, point number one, it says that it detects IR. Okay, IR stands for infrared. Okay, let us take a moment to understand what infrared actually is. Well, infrared is actually electromagnetic radiation. Okay, it comes in the far end of the red color of the spectrum of visible light. Okay, so right after if you talk about the visible light range, right after the red color comes infrared, which has the wavelength lesser, or I would say the frequency will be much lesser and the wavelength will be much higher, right? So these kind of radiations will be called as infrared radiation. Now, where do we see this in our day-to-day life? Any object which is warm and we can feel that warmth usually comes from the infrared radiation. Okay, so that warmth can be felt by infrared radiation. Okay, I'll give you one example. For example, our body, we all human beings are warm-blooded animals. Okay, now because we are warm-blooded animal, we emit our own heat. Now this heat can be detected by infrared cameras, right? And which are basically nothing but temperature cameras. Okay, and they create a heat map of what they are of what the camera is actually seeing. So basically our human body emits infrared radiation, but the radiation is very small that and basically infrared radiation is something that we cannot see by our naked eyes. Okay, also a hot vessel can also release infrared radiation. An animal can also release infrared radiation. Okay, so basically what happens is any hot object which is in the vicinity of this sensor, this infrared radiation coming out from that object is sensed by this sensor, the PIR sensor, and that's how this sensor actually works. Okay, and that's the reason the name is passive IR sensor. The word passive over here signifies that it's not emitting its own infrared radiation, rather it is waiting for some external source of IR to come and then it will detect that IR radiation. I hope so this is clear to all of you, right? So one thing that we need to keep in mind, that it actually detects IR. Okay, it detects IR and hence the name is passive IR. Then it is ideal for detecting motion from object which emits IR. If we are expecting that this sensor will work by just movement coming in place and movement of object which do not release infrared radiation, then that will not work. The sole reason or the sole purpose of this sensor is to detect infrared radiation, and if it gets infrared radiation, then it assumes that there is a motion happening in front of it, and therefore this sensor will say that, hey, I have detected a motion. Okay, now where can we use it? Like, it can be used for warm bodies like human body, animals, and warm objects. Okay, so typically places where IR can be released or objects which can release IR, that motion can be detected over here. Okay, not exactly detects motion, but we can use it as a motion detector. Okay, fine. So this is how the PIR sensor actually works. Okay, now let's go to its diagram. This is how the PIR sensor looks like. And the second most important thing that we always talk about any sensors is the terminals. Okay, so over here we have three terminals. We have the power terminals. Power terminals will always give the power to the component so that they can work, so that they can function. Okay, so we have power and we have ground. So this will complete the circuit. Power will be in, ground will be out. Then we have the signal pin. Now this signal pin will actually tell you whether the motion is detected or not. Okay, whether the motion is detected or not. If the motion is detected, the signal will be high, and when I say high, the voltage will be 5 volts. Okay, it will release a 5 voltage current. Okay, however, if the motion is not detected, then the signal will turn into 0 voltage, which means there will be no current flowing at all. Now with this, if you remember the concepts of digital signals, we understood that digital signal will be either high or low, either yes or no, and that's exactly what this is giving. It is giving us either high voltage or low voltage, nothing in between. And that's how we are going to use this sensor to connect with digital pin and use its output as an input for the Arduino board. Okay, output from the sensor will be the input for the Arduino board. I hope this is clear to all of you, right? Okay, and we will be using this as a digital signal, and then that signal will be a deciding factor for us to change the state of the piezo buzzer as well as the LED. Okay, using the if and else condition. I hope this is clear to all of you, right? Okay, moving ahead. Fine. So our objective for today's session will be, first of all, this is a design that we will be making. We will be connecting the PIR sensor with the power lines. So the power supply will be of 5 volts. So 5 volt will be connected to the power pin, and then ground will be connected to ground, and then finally the signal pin will be connected to any one digital pin. So we have around 14 digital pin. You can select any one of them. Okay. Then you can connect an LED with any one of the digital pin. Along with that, if time permits, we'll also add a piezo buzzer over here. Okay. And again, if you remember yesterday's session, piezo buzzer can be connected with any of the digital pins. Okay. So that's how the circuit diagram will look like. Now let's talk about the code, pseudo code. Okay. The program pseudo code. So create a temperature monitoring alarm system. We have already talked about the design. Now we'll be talking about the pseudocode. The pseudocode will look like something like this. The very first step that I'm going to do is going to sense the motion. Okay, we'll see whether the motion is there or not, whether the motion is there or not, whether the motion is there or not. Every iteration, the very first step that we're going to do is we're going to see whether the motion is there or not. Okay, that is step number one. Whatever is the finding, we will we'll save that in a variable. Okay, we'll save its state inside a variable. Alright, I hope so this is clear to you. Okay, then the next thing is, then we'll say if the motion is sensed, then what are we supposed to do? Okay, then what we are supposed to do? Okay, in that case, what we'll do is we will do two things over here. Okay, we'll do two things over here. Okay, two stuff. So the first step is turn the buzzer on at 250 frequency and then turn on the lights. Okay, and then turn on the lights. Okay, so these are the two actions that we will do if the motion is actually sensed. Okay, if the motion is not sensed, then we'll do the reverse of it. The LED will be turned off and the buzzer will be turned off. Both of these two things will be turned off. Once this is done, then we will wait for a second and then repeat the entire thing once again. Okay, so that's how we are going to go about it. That's how the pseudocode will look like. I want all of you to take a screenshot of this screen so that you can keep this as a reference for you whenever you want to use this. Okay, done. Alright, let's move ahead now. Now we'll do the practical aspect of it. I want all of you to pay attention. Okay, fine. So we'll go out of our presentation now and then we'll start with a Tinkercad. So open a Tinkercad and from here you will create a new project as we always do in our everyday session. Okay. Once your project is created, then you can move ahead and take a Arduino board. Once Arduino board is there, you take an LED because we know that what are the things that we need. So I'll just take the LED also from here. Okay, so we have the LED with us. We'll refresh the page once to place the Arduino board at the correct place. And here is my LED. Just a second, let me readjust it. We'll refresh once again. Okay, so we have the LED over here. We'll increase the size, this is too small. Alright, okay, so now we have adjusted the size of it. Now we'll be moving ahead to the next part. Okay, so from here we have taken an Arduino board and then we have the LED. Okay, apart from that we'll need a buzzer and a PIR sensor. Okay, here is a PIR sensor and then here is the buzzer. Okay, we'll just refresh the page once again to place everything at the right place. Okay, we can just shift this over here. Here we'll have these two things. Okay, and then the final stuff that we need is a piezo buzzer. Okay, did we get the piezo? No. So we'll just add this over here likewise. So we have the view of all the pins right now. Okay, and once our entire diagram is created, then I'll zoom out a little bit so that you can see the entire view of the project. Okay, fine. So what I'm going to do is, the first pin that we have over here is a signal, and I'll connect this signal to any of the digital pins. So let's say I'll connect it to pin number 3. Okay, so this was my signal pin. Okay, then we have the ground. Ground will be connected to ground, and then again, sorry, this will be power and this will be ground. Okay, if you see in the mouse, you will see that this is the ground pin, right? So I'll connect this ground to actually ground pin. Let me delete this and this one too. So ground will connect to ground. Ground will be connected to ground, and power pin will be connected to 5 volts. Okay. Now these wires might be very confusing, so what we'll do is we'll arrange it in the proper order and we'll color it so that we don't get confused with too many wires in our system. Okay. So what I'm gonna do is I am gonna add multiple points in my wire and try to make it look much more better. Okay. Again, multiple wires over here also. So here we have properly placed one wire, and then if you want you can change the color of it also. So this is ground wire, and I always like to keep ground wire as black. Okay, then we have this, and we can add one more point over here like this, and because this is the power pin, we'll select red color. Okay, I have already mentioned this, that colors actually do not matter, it's just for our reference to understand that which wire is doing what. Okay, fine. So this wire can be turned into purple so that we know that this is actually a signal pin. Okay, fine. So now the next thing is that if you remember in previous session, in the last session, we used one resistor for the buzzer also, right? So I'll just use this buzzer. Okay, we'll bring this a little bit up, okay, so that we have some space, and then I'll move it upside. Okay, a little bit more, and then I'll just flip it, and we can connect this to the resistor. We'll keep the resistor as 1K itself, and then you can select this one with any of the I would say digital pin. This can be connected to the ground pin. Okay, and I'll just color it black. Okay, just let's okay, then let's take the LED also. Okay, and LED ground can be connected to ground directly. Okay, and I can add one more wire over here just to make it clean, and then this pin can be connected to any of the digital pins, and just for the sake of making it look better, we can just move it. Okay, so this is how the connection has been done. Okay, so now we are using basically common ground pin for both piezo buzzer as well as the LED. Okay, and that can be done, that's not a problem at all. Okay, so now here we have the PIR sensor, here we have the buzzer. Okay, and buzzer comes with a connected resistor in it. Okay, I believe this is all clear to all of you. Okay, now since the connection is done, now we need to note down all the pin numbers that we have used in our program. Okay, so the pin number, the digital signal that will be as an output for this PIR sensor will go to pin number 3, and that will act as a input. Then we will output the current to the piezo and the current to the LED. So pin number 5 and pin number 9 are both going to be what? They are going to be output. Okay, so this is very important to decide that which pin will play what role. Okay, now once we have decided that, I can go to code and then click on text and then change it into text, and now what I'll do is I'll remove the entire code which is already present over there. Okay, once that is done, then we can do the programming for it. Okay, and I really suggest all of you, if you want to really learn Arduino programming, it's always best to start from zero, from an empty template. This will give you a boost, and this will help you to remember the functions and all the coding syntaxes that you actually need to remember to do the programming aspect. Okay, so let's start now. Okay, first of all, what I'm going to do is I am going to write I'm going to create a variable, and let's name this variable as sensor val. Okay, and I'm not going to do anything with this. It's just declared but not defined. Okay, it's just declared but not defined. Okay, now inside void setup, I am going to write all the pin modes. Okay, so we are going to use total 3 pins. Pin number, if you see, pin number 3, 5 and 9. 3 is going to be input, 5 and 9 is going to be output. So we'll just write the same thing. So we'll say pin mode, okay, pin mode, and then here we have 5 comma, and then what mode are we supposed to write? So the mode will be, I'll say input, and input all will be capital. Okay, then right after that, let's see if we can highlight this. Okay, fine. Then we'll write pin mode. Okay, and inside pin mode, I'll say pin number 9 is supposed to be output. So pin number 9 is supposed to be output. Okay, likewise moving ahead, then we have pin mode, open close brackets, and then from here we'll say pin number 9 is gonna be again output. Okay, so now we are done programming the setup part. In setup, what we did is we made sure that all of the pins mode are already declared over here. So 2 pins will work as output, and 1 pin will act as input. Okay, let's move ahead. If you remember, the first thing that we're going to do is to sense whether that motion is detected or not. Okay, so the very first thing in the loop is that we are going to see if the motion is being detected or not. Okay, and how that can be done? Once the PIR sensor detects the motion in front of it, it will send a signal 1. So we need to see if pin number 3 is actually getting the signal 1 or not. Okay, signal 1 means voltage is high. Okay, so we'll check that. By the way, I have written the wrong pin numbers over here. So pin number 5 was over here. Then we have pin number, okay, pin number 3 will be input. So I'll just write pin number 3 as input, and always make sure that you're writing you're using the correct pin numbers, or else your code will not work even if your code is completely correct, right? And it's always necessary to check the pin numbers double time. Okay, it's always necessary. Okay, moving ahead. Now we have the sensor. Let's say sensor val. Okay, so sensor val will be equal to, okay, sensor val will be equal to 1. Now we are basically taking the input value from the sensor, right? So, and what kind of signal it is? It is a digital signal, and therefore what are we going to do is we are going to sense that digital signal. To sense a digital signal, the function that we are going to use is digital read. It's very similar to analog read. Okay, so I'm going to say digital read. Okay, and then inside that I am going to put the pin number that it is supposed to read the value from. So the pin number over here is going to be what? The pin number is going to be 3. So I'm going to say pin number 3. That's it. Okay. Then after that, I want to see what is the status of it. Okay. So this value, this digital read will store or bring either high or low value. Either high or low value. Okay. So what we will do is we'll check whether the sensor val is storing high value or low value, and accordingly we'll take the decision. So here we'll have a if condition. Okay. So here we'll say if open close brackets, and then again open close brackets. Okay, and then inside if we'll write the condition. So condition is that if sensor value has high value. Okay, so we'll say sensor val is equal to. Okay, so this is the comparison operator. Okay, equal to. There are many students who do mistakes in writing only equal to symbol once. So you're not supposed to write only once, it should come twice. Okay, that's the comparison operator. If you write only one, that is assignment operator. Okay, now over here if you see sensor value is equal to, you will say high. Okay, moving ahead. So we have if sensor value equal to high. If you don't want to write high, you can also write 1. That will also make sense. Okay, high and 1 both are the same thing. Okay, so 1 also means that the signal is there. High also means that the signal is there. So you can write either 1 or you can write high. Okay, now once this is done, then what we are gonna do is I am gonna write digital write in this LED. Right, so I am gonna say digital write, and then I'll need to write which pin number am I supposed to write it to, right? So I am supposed to write in pin number 9. What I'm supposed to send the signal to? I want this LED to set to high because motion is detected. If the motion is detected, turn the LED on. Okay, moving ahead. And if you remember the function to use or to activate a buzzer, it was tone. So we're gonna use tone over here. Okay, so and that's the reason why watching this entire series in a sequence is really very important. Okay, because we are gonna use things that we have learned in the previous session in this project. Okay, so tone. Now what is the key? What is the pin number that we have used for piezo buzzer? That's gonna be 5. And what frequency do you want the sound to be produced of? So we'll say 250. Okay, so yeah, so tone 5, pin number 5, send a frequency of 250 to be to activate the buzzer. Okay, with this I'll just remove this extra space, and then here I'll write else, and then we have inside else we'll write the code. Okay, now basically it will be the same 2 lines, digital write and tone, and we'll just do some modifications in it. Okay, so I am gonna write digital write, and then from here I am gonna use the same thing, 9 comma, but this time rather than high I'm gonna say low. Likewise the same thing, right? Rather than having tone, I want to turn off the buzzer. Okay, and to turn off the buzzer I'm gonna say no tone. Okay, so no tone in which pin number? So pin number will be what? Pin number will be pin number 5. Okay, and with every iteration I will have a delay. Okay, I don't want this to happen every fraction of second. I want to keep it a delay. So let's keep it a delay of 1 second. 1 second will be 1000 milliseconds, and that's how your entire code will be. I want you all to take a screenshot of this so that you can do this yourself. Okay, now to check if this is working fine or not, we'll click on start simulator and then turn off the code. Now the simulator is connected, and now if I click over here, it will actually simulate an object. Okay, let me zoom out a little bit. Yep. Okay, if you click on this PIR sensor, it will simulate an object for you. Okay, so this is the range in which the PIR sensor is actually working, and it will actually sense the motion in this range, and this is an object that you can actually move. Now if you move this object with your mouse cursor, okay, then ideally what should happen is that this movement signal will be sent to Arduino. Arduino will take the decision and accordingly will turn on the buzzer and the LED light. And if there is no motion detected, then these two things will be ideally off. So if I move this, technically the buzzer will turn on and will get a sound produced. This sound will alert everyone at home or wherever you are installing this project. Okay, let's try that. Okay, so see. And the moment I have stopped moving this object, the sound has stopped. Okay, again the same thing. If you move it again, the moment the motion is detected, the buzzer will turn on, and the moment the motion is stopped, the buzzer will turn off. Any which ways, if you see, there was a blast symbol also coming up over here, right? And this blast symbol can be rectified by adding a resistor in the LED. So we can do that also. So we'll do that. I will just remove this wire and place this LED a little bit above. Okay, we can basically remove this point. Okay, and then I'll take one more resistor connected over here. We'll change the resistor value to 450, not kilo ohm but ohm. Okay, and then connect this back to pin number 9 if I'm not wrong. Okay, we'll make the connection a little bit better. Alright, now if I click on start simulation, let's try to see if that works for us. So now if the motion is detected, things are working fine, and now we're not even getting that blast error also. That blast error was actually coming because we were supplying more current than the LED was able to withstand. Okay, and that's why we were not able to get that. Now again, if you move, so that's how we created this project. Dear students, I believe that this will be really helpful for you. You can use this project to install in various places. It can be kept at places where you want to keep a count of people going in the room and going out of the room. You can also keep in install this in places where you want to keep something very safe, or you can also use this system to keep your pet animals safe, right? So all of these places are where you can use this for your own benefit. Okay, moving ahead to the slides once again. Now since we have completed this entire project, now we can move ahead and see how much you have learned in today's session. So here we have quiz questions for you. Okay, so let's see that who answers this quiz question. I really want all of you to answer these questions in the chat section. I want this session to be interactive. Okay, fine. So yeah, moving ahead, quiz time. So first question for all of you, we have total 3 questions. First question, what is the primary function of a PIR, passive infrared sensor? Okay, here are the options for you. Tell me which option is correct, A, B, C or D in the chat section really very quick. Let's see that how much you have learned. Well, that's really very good, amazing. I can see a lot of responses. Well, the correct answer over here is B. So all the people who have answered B in the chat section, absolutely correct. You are absolutely correct. The main function of the PIR sensor is to detect motion by sensing infrared radiation. Okay, that is the main purpose of PIR sensor. Moving ahead, next question. Question number 2. Which type of pin is typically used to read the output of a PIR sensor? Okay, which pin are we using to get the input from the PIR sensor? Is it a digital pin, analog pin, PWM output pin or ground pin? Tell me A, B, C, D in the chat section really very quick. Well, I can see a lot of answers coming in. Let's see the correct answer. Yes, digital input pin is the pin that we are going to use to get the output from the PIR sensor in the Arduino board. Okay, so digital input pin is a pin. Third question and the last question. If a PIR sensor is detecting motion, what signal does it send to the Arduino? Okay, what signal will it send? Will it send high signal or low signal, or whether it will send an analog signal between 0 volt to 5 volt or no signal at all? Tell me A, B, C, D in the chat section very very quick. Well, that's really nice. I can see a lot many answers coming in. Great, wonderful. So the correct answer over here is option number D. This is 5 volt high. If the motion is detected, the voltage will be high. High volt refers to 5 volt in Arduino board when we talk about digital pins. Okay, for different boards, the definition for high in terms of voltage might differ. So it's always good to read the manual of the board that you are actually learning from. Okay, moving ahead. Well, so we are done with today's session. In tomorrow's session, what we are going to do is we are going to work with motors, and not just simple DC motors that you have been playing with your in school. we are gonna use a smart motor which is called as servo motor. Now the best part of servo motor is that it knows that how much angle it is moving, and we can actually pass the values in degrees to make it move to a certain angle. Not only that, we can also create a lot many angles, and we can learn a lot many geometrical stuff using this project. So make sure that you are completely aware about tomorrow's session. You know, add it in your to-do list so that you can join this session without any fail. Okay, so this is the project for tomorrow. We are going to work with the sensor, the servo sensor. Okay, by the way, if you really like our sessions and you enjoy being with us, make sure that you download the sisyaclass app. This will give you access to many more classes of different subjects, be it chemistry, physics, maths, biology, and coding, robotics as well. So make sure that you download our sisyaclass app, join our class to know more. Okay, and do not forget to share your love by liking the video, by sharing the video, and by subscribing to our channel. By subscribing to our channel, it will make sure that you are not missing on any of the updates that we are coming up with. Every week we come with new series to enhance your skill. So make sure that you are liking, sharing, and subscribing this channel. Well, thank you so much for being with me in today's session. I'll see you in the same time tomorrow with a new project. Till then, bye bye.